Okay. All right, folks, last video. We're on to page 7 now. Page 7. Now, this says, draw the force diagram, calculate the weight, and find the tension in each cable. So tension is just the tension force, okay? Ft. So what's the Ft of the cable pulling up? So let's look at this, and remember that weight, we can also think of weight as Fg. So how much is gravity pulling down on the sign? Well, we remember that Fg is equal to mass times g. So if I'm looking for Fg, all I have to do is take my mass, which is 25 kilograms, and multiply it times 9.8, which it says is my g. So once I do that, 25 times 9.8 equals 245. So this is, I don't know why it always does that. So my Fg is 245 newtons. When it asks for weight, give them the answer in newtons. All right, now the tension force in each rope. Well, I know that if the sign is not moving and I've got 245 going down, then I also have to have 245 going up. But I see that it's not one cord, it's actually two. So they're going to split that 245 in half. So let's go over here. Oh, man. 245 divided by 2, 122.5 for each rope. 122.5 newtons each. That's just 245 divided by 2. And if we wanted to get fancy, we could even do something like Ft equals 122.5. How about that? Now, force diagram. Let's just draw these two forces, okay? So I know that I've got Fg from the Earth. And now I've got two different arrows that are going to be going up. But remember that my two arrows have to add up to be the same length as, and actually let's just do this. Whoops. Okay, so if I make two arrows that add up to the length of my other arrow, and hopefully they're roughly the same length. Oh, they're not. Uh-oh. Well, I screwed that up, didn't I? Let's try that again. Let's see. Halfway looks like it's about there. So if I do an arrow like that, and an arrow like that, let's see if I can get that again, okay? So I've got one going up. Well, here's what we'll do. Just make them the same length. All right, so I've got both of my arrows going up, and I want them both to be about half the length of this one, so that if I add them together, I should see that they balance each other out. If it's not perfect, obviously, if I can't make it perfect, I'm not expecting you to have it perfect, but I should see that they're shorter. Now, that's Ft from the rope, and then the other one is also Ft from the rope. So we got to label both of them, okay? So I've got two tension forces and one gravity force. So that's everything they asked for there, okay? That's the weight of the sign, the tension in each cable, and the force diagrams. That's all three things. That says a box with a mass of 10 kilograms is pulled across a frictionless surface with a constant force of, oh man, that didn't turn out nice. I'll change that. You guys won't look like this. That should be there. So a constant force of 20 newtons. So if we look at the box and we think about this, the net force, well, I know that I've got gravity and I know that I've got normal, But those are balancing each other out. So I'm for net force, let's just not even think about those two things, okay? Now I know that I've got 20 newtons going this way. And this says frictionless. So there's nothing going back that way. So the only force acting here is 20 newtons. So don't get tripped up and think that there's more to this than there is. If it tells you there's 20 newtons, the answer is just 20 newtons. Now it says describe the motion of the box. Now we know that if there's a net force, force equals acceleration. If you don't have that on your card, put it on your card. Force equals acceleration. So if there's a net force of 20 newtons, that means that the box is going to be accelerating to the left. All right, so it's moving to the left and it's accelerating. It's picking up speed. So let's draw a motion diagram for that. So we know that it's starting off not very fast, and it's gradually getting faster. So I have to see my arrows getting longer as the box moves to the left because it's accelerating. That force is causing acceleration. Okay, now on my motion diagram, I don't want to forget my acceleration arrows. Anytime something's speeding up, then the acceleration arrows are going to go in the same direction as the motion. Now, I didn't do a great job, but all those arrows should be the same length, okay? In fact, let's just do that. Let's, actually, I like that arrow. Just to make sure these are all the same length, I'm just going to go ahead and copy them and paste them so that I know that all of them are the same length. Okay? So I've got my acceleration arrows, they're all the same length. Now this says, draw a motion diagram for the same situation, but the box, instead of being 10 kilograms, okay, instead of being 10, now it's 20. So we know that when there's more mass, it's going to decrease the acceleration when there's the same amount of force. And that makes sense, right? So if I push a heavier thing with the same force, I'm not going to speed it up as fast. So I'm going to draw another motion diagram, but this time it's not going to speed up as fast. So they're going to gradually, but I'm making it more gradual this time. Okay? So we're not seeing the big jumps we saw in the other one. And now my arrow, okay, needs to be, and let's see if I can do this. Okay. So my arrow needs to be smaller, specifically about half the size, okay, of the other arrows. Oh, I forgot some arrows. It's okay. Copy. Here, I forgot to draw a few arrows. Let's go ahead and draw those. So these are my velocity arrows. In a minute, I'm going to put all my acceleration arrows on. All right, so there we go. Now, I'm going to put all my little acceleration arrows on. Whoa, I don't want to do that. Paste. Paste. So all these arrows are going to be the same size. And notice that all of them are smaller. So this arrow is smaller than this arrow because the box is not accelerating as fast. So it's shorter than the faster acceleration. All right, so there we go. That is the last of the videos. You should now be trying page 8, and you've got answer keys for all the pages that don't have videos for them. Good luck, and if you have questions, ask Mr. McSparron.